Let's talk about computing area contained by parametric curves. So we have our two important formulas at the top of the page in red here. You're either asked to find the area between a parametric curve and the x-axis or the curve and the y-axis. So I have one example of each in this video. For the x-axis, we integrate from alpha to beta. These are your time values. Y of t, x prime of t dt. And then for the y-axis, very similar, but the integrand is x of t y prime. Okay, so for this first one, we're asked to find the area between this parametric curve and the x-axis, and we're given a rough sketch of what this looks like. So we're not given an interval of time or x values because there is a finite little area contained between the curve and the x-axis here. So we have two jobs, not just to set up this integral and compute, but we also have to figure out essentially the alpha and the beta values here. So these are the time values of this point and this point in the correct order. So at both of those points that I've marked, this is where it crosses the x-axis, so it's where y equals 0. So we're going to set the y formula 2t minus t squared equal to 0. And that's where we're going to find those t values. So I can factor this. And I get that t is 0 and 2. And you'll notice this kind of feels unexpected because the way this image is drawn, either one of these could be 2, it's not labeled, but definitely neither of them is 0. But notice these are time values, and what we're looking at here is the x-axis. All right, so at t equals 0, the x value is 0 cubed plus 1, and the y value is 0. So 1, 0 is this point right here in terms of x, y. And then at t equals 2, the x value is 2 cubed plus 1, that's 9, comma, the y value, which is still 0. So 1, 0, and 9, 0 make more sense with what we're looking at. But these are the alpha and the beta for our area. Okay, so this area will be the integral from 0 to 2, because it's dt. And then we're doing the x-axis here, so it's y of t x prime. Y of t times x prime. And what we have is a definite integral in terms of t. To compute, I'll distribute in the 3t squared. So I have 6t cubed minus 3t to the 4. Antiderivative. Oops, not the 4. This should be a 5. So I have my antiderivative. We'll quickly check that this guy's derivative is the function above. Yep. All right, so this evaluated from 0 to 2. So I have 3 halves, 2 to the 4th, etc. Okay, so this will be 3 times 16 over 2. So that's 3 times 8 is 24. Minus 2 to the 5th is 32. So we have 96 over 5. Why don't we leave it there? Whatever 24 minus 96 over 5 is, that'll be the value of this area. Okay, and then we have an example of the other option. So this example we just did was area between the curve and the x-axis. This one switches it to a new curve and the y-axis. And again, we have kind of just a rough image of what this graph looks like in the xy plane. So we're talking about this area here. Because this area is to the left of the y-axis, this is the equivalent of being below the x-axis here. So we're expecting a negative integral here. And again, we are not given any time values or xy points because we can figure it out. At each of these points, this is where the x is 0, right? These are y-intercepts. So I'm going to take the x formula, which is comically similar to the the one in the last problem. This is the x formula equals 0, and I will solve. And again, we get t equals 0 and 2. We don't have to actually find the x, y points that go with these t values, but I like to do it, which it kind of like confirms and orients me in the picture. So at t equals 0, the x is 0 and the y is 0 squared is 0. So that's this point right here, 0, 0. Makes sense given the image. And then when t equals 2, the x value is again 0. The y value would be 4. So 0, 4 is this point up here. Okay, so this one again will have the area is the integral of, or from 0 to 2, because these are the time values. And then if we're doing y-axis, it'll be x times y prime. So the x formula times y prime. And we'll compute this very similarly as the other one. Distribute the 2t in. 2t cubed minus 4t squared. Antiderivative. Plug, plug, subtract. So here we have 16 over 2 is 8. And then 4 times 8 is 32 over 3. Right, so that gives us 24 minus 32 would be, or I guess we could leave this as the other one. Yeah, why don't we just leave this 8 minus 32 over 3? This one isn't quite as bad, but I'll keep this in the same form as the last example. And that will be a negative number, which is this net area between the curve and the y-axis.